All right, the second section of Chapter 8 focuses on the long run. And so remember, what's the difference between the short run and the long run? Well, the long run is a period of time that's long enough so that all inputs are variable or can be changed. So again, it's not a certain period of time, like 3 months, but it is defined by whether or not you have enough time to change all of your inputs, including the size of your factory, number of machines you have, and the number of workers you hire. Okay? So this is the long run. And there is a discussion, in fact, at the beginning of the chapter. And so you should read this, Startup, Street Cleaning Around the World. And it describes how in China, in the morning, in the cities in China, the people cleaning, how do they get the streets clean? People use brooms and dustpans, and they clean the streets. But how do we clean the streets here? Well, we have big machines, right, that go down the street and clean it. And if you park your car there, you get a ticket. Right? So that's a big difference, right? Why is that? Well, it turns out labor is a lot less expensive in China than it is here. And why is that? Well, that might be a more deeper question than we want to get into. So I'll probably edit that out of the video. But here's a quick answer for it. It's difficult for Chinese workers to come to the US and work. Right? You have to get a visa, and everyone who wants to come to the US to work can't come. Doesn't get a visa. And so therefore, we have a high wage rate here. And normally that would attract people. And then what would happen to supply and demand of the labor market in the US? What would happen? Supply would increase, right? And the wage rate would fall. But partly because people don't want to see the wage rate fall, we restrict immigration, right? So that's one reason. What about the cost of capital in China versus the US? So do you think the cost of one of those big machines is more expensive in China or the US? No, just the cost of the machine. We know that the cost of labor is much lower in China. What about the cost of the street cleaning machine? Maybe more expensive, maybe cheaper. I think the same. Why? Because unlike labor, who can't cross borders, machines can cross borders much more easily. Right? There may be some tariff or import tax, and so maybe there's a little difference in the price, but generally, the company who makes these machines, I don't even know where they're located, right? They could be in the US, they could be in China, they could be in Europe. And they sell their machines all around the world, and there's generally free trade in products. But there's not free trade in labor. That's because of immigration laws. Anyway, thinking about how capital and labor is used in production processes is an interesting question. And this section is on choosing the factor mix that's between labor and capital. And basically, this is an application of marginal thinking. So if the marginal product of labor per dollar is greater than the marginal product of capital per dollar, then what should you do? Hire more labor. So what is the marginal product of labor? This is the additional number of jackets, right, or additional output you get from adding an additional unit of labor. And how much does an additional unit of labor cost? In our examples, we said it costs $100. Yeah? So if the marginal product of labor is, say, 2, you get 2 jackets if you hire one more worker. The cost of that worker is 100. This would be 2 over 100. Yeah? But what about marginal product of capital? We haven't really talked about this, but it's calculated in exactly the same way. Say you're thinking about buying one more sewing machine. And that will add 2 jackets to your production process. But the machine costs $1,000. So it's 2 extra jackets by getting the machine, which costs over 1,000. So the machine is 1,000. So 2 over 1,000. So what should you do? Where should you allocate your dollars? To hiring more workers or buying more machines? In this case, more workers, because we said it was 2 over 100, right? Which is 1 over 50, and that's bigger than 2 over 1,000. Right? And they have some different numbers here in the text, and that's basically how you would think about allocating your resources into labor or capital. Wherever you get the most bang for your buck. That's all this is really saying. Alternatively, if the marginal product of labor per dollar is less than the marginal product of capital per dollar, then you would put the money in machines. This equality sometimes confuses students. And what this says, what they say in the text here is, you should keep hiring workers until the marginal product of labor equals the marginal product of capital per dollar. Again, both in per dollar terms. Right? And vice versa, you should keep buying machines until the marginal product of capital equals the marginal product of labor. And so they say, why is it that right when they're equal, the profit is maximized? Right? And so, same thing we saw before in chapter 6, when the marginal benefit and marginal cost are equal, total net benefit is maximized. And so it's the same type of principle at play here. If marginal product of labor per dollar is greater than marginal product of capital, then it makes sense to hire more workers, right? And you should continue to hire more workers until they're equal. So it's not really the fact that they're equal that matters. It's the fact that you get more bang for your buck by putting your money in the higher valued one, right? In the more productive input. But as you do that, we know from the law of diminishing returns, the more you do something, you're more likely to have more cooks in the kitchen, so to speak, and so the marginal product eventually is going to fall. And so the more labor you hire, the marginal product falls. And so that's why it happens to be maximized at where they're equal. But it's because you keep adding workers until they're equal. And it's possible that you have more factors of production than just labor and capital. We also might have natural resources, or different types of labor, different types of capital. There could be n inputs, or factors of production. And that equality would hold for all of them if managers are maximizing. The next subsection is about costs in the long run. And this figure appears in every Principles of Economics textbook. So let me explain what this figure shows. So again, cost is on the y-axis. Sometimes if you want to save yourself some time, you can just put dollars. We're measuring it in dollars. And then this is thousands of CDs per week. This is the quantity. So let's say we have a small factory that makes CDs. Do you guys know what CDs are? These are little discs of plastic that they used to put music on. So if you have a small factory that makes CDs, this is what your average total cost curve looks like. Say we're in the short run. We can't expand the size of the factory. If we increase the number of CDs that we make from 6 to 10, our average total cost falls. Right? Our cost per unit goes down. And if we go from 10 to 14, we find that we're at the minimum of our short-run average total cost curve for a small factory. But let's say we have a hit single, and we need to produce more CDs. So we need to produce now 20,000 CDs. Now our cost per unit falls. Our cost per unit rises, right? Because we're here on the short-run average total cost curve, our cost per unit rises. So what might we think about doing with our small factory? Expanding it. So we build a bigger factory. That would be this factory here, ATC 30. So maybe this is 20 units of capital, or maybe 20 square feet. And this is a 30 square foot factory. And so what happens when we build a new factory? Our entire average total cost curve shifts from here to here. Okay? Before, our average total costs were rising because the workers were running into each other trying to make 20,000 CDs. But if we build a bigger factory, they're not going to be running into each other. And so our costs will fall, and we can produce our 20,000 for a lower price, lower cost, right? But if this single really blows up, and we need to produce 35,000, our costs are going to start to rise, right? And then so we might think about building an even bigger factory. And that would be factory 40 square foot factory. Right? And so notice what's happening as we go from a 20 square foot factory to a 30 square foot factory to a 40 square foot factory. The minimum point of the average total cost curve is falling, right? And so this red curve is called, in mathematics, an envelope curve. So imagine we could have many, many factories, right? We could have a 25 square foot factory. Or we could have a 35 square foot factory. We have all these possible factory sizes. And if we plot the short run average total cost curve for all of them, and then connect the bottoms of the curves, we'll see that they take on this shape. So this is an envelope curve, and it is the long run average total cost curve. That's what this curve is. And so as we expand output, at first our long run average total costs fall. But as we expand output even more, our average total costs rise. And so this part where they're falling, we have falling long run average total costs. And we call that economies of scale. And then this section here, where we have rising long run average total costs, we call this diseconomies of scale. So whether we have economies of scale or diseconomies of scale really depends on where we are producing, right? And so economies of scale is something of an important concept in the sense that people out there in the real world use this term. Unlike the economist's term utility, nobody out there, whatever job you get, unless you become an economist, uses utility like economists do, but they do talk about economies of scale. So you should know the definition of economies of scale. So economies of scale, when average costs fall as output rises. And so why might this be? Why might we have economies of scale? Well, the bigger factory that we have, the greater specialization there can be between the workers. And so we saw that not only is there specialization, the worker gets really good at doing one little task, but they can also work together. However, if we have such a huge factory, it becomes difficult to coordinate the activities of the people who are making the CDs with the people who are recording the music on the CDs, with the people who are putting them in boxes. Because it's such a huge factory, then in fact, when we try to produce so many CDs, our average costs begin to rise. And so, luckily nowadays we have MP3s, and the marginal cost of producing an additional MP3 is what, roughly? Roughly 0, right? Because once I make the file, including this file that I'm making right now, once I record this, I can distribute it to the whole world if they have a computer, and all they have to do is download it from my website, right? So the marginal cost is 0. So that's the information revolution. And I think that's it for this section.